So, moving on to our next speaker, I would like to introduce you to Clement Huang. Clement is a current tech lead at Credit Karma, specializing in front-end and GraphQL, and he previously entered on the React team at Facebook, shipping JSX fragments. He previously founded a contracting company called ZooHouse.io. This will be his first time speaking at a conference, but he has done company talks before. So Clement's talk today is about how Credit Karma shipped a COVID-19 relief center in a week. And let's all say hello. Hello.
Hi, everyone. Thanks for having me today, and thanks for the introduction, Chrissy.
Thank you so much for being here. How do you feel?
A little bit nervous, but we'll see how it goes.
I'm sure you'll do just fine. I know how much work everyone put into their speeches, so I have no doubt it's going to go amazingly. So I'm not going to stay here and hang around for too long. So there it is. So I'll pull up your presentation now, and I'll see you after your talk. So good luck.
Thank you. All right, so I'm a software engineer at Credit Karma, and today I'll be talking about how Credit Karma shipped Project Relief in a week. And I'm sure some of you might have some questions at this point. What is Credit Karma? What is Project Relief? And who am I really? I'll be going over these briefly, so without any further ado, let's jump right in. By the way, I posted my slides on my website, clemmy.ninja/reactgeeko2021, so you can follow along. So let's start with who I am. During the day, I'm a software engineer employed by Credit Karma. I have a primary focus on product engineering and building wonderful experiences using React and GraphQL. And I also dabble with some of the platform teams from time to time. And here's a fun fact about me. I'm also the CEO, that is, the Chief Eating Officer. You'll usually find me in the kitchen snacking on Hello Panda after I'm tired of playing whack-a-mole with the CSS. And here's a picture of me bringing my favorite fruit to the office. For those of you who know what this is, give me a fire emoji in the live comments. And for those of you who don't know, this is durian, and it's not only one of the world's stinkiest delicacies, but it's also one of the most divisive of them. You either love it or you hate it, and if you haven't tried it before, I definitely recommend trying it out and choosing your camp. You might just discover your new favorite fruit. By the way, I'm also the guy who brought fragments to React. Yes, I'm full of controversy, I know. But that's enough about me. Let's talk about Credit Karma. In a nutshell, Credit Karma is a company whose mission is to empower each and every one of our members with the knowledge, tips, and tools they need to turn their financial dreams into reality. We have over 100 million members who depend on our free product offerings. These include things like credit reports, scores, and monitoring, like mortgage refinancing calculators, personalized offers, checkings and savings accounts, tax filing, just to name some of the things that Credit Karma has to offer. And one of our most recent offerings was Project Relief. In March 2020, the World Health Organization officially declared COVID-19 to be a pandemic. This financially affected a lot of people. Many people experienced job loss, they were furloughed, or they had their hours reduced. And many of these people actually barely stayed afloat, and some even started to slip into debt. It wouldn't be long before many people ran out of money or had to dig into their retirement funds. This meant that time was of the essence. People needed help, and they needed it quickly. So Project Relief was ideated to help members navigate their current crisis financially. For our first iteration, we wanted to be able to connect our members with benefits that they're eligible for based on their financial situations. There were hundreds of benefits available online, yet many consumers felt overwhelmed by the amount of information out there and actually found it very difficult to understand what governments and private benefits they were eligible for. And we were actually able to build and deploy our first iteration of Project Relief in only a week, which was a huge success for us. With great velocity, we were able to ship a personalized experience that helped connect our members to the resources that they needed to increase their cash flow and release some of their financial stress. However, 1 year ago, this kind of velocity was actually not possible at Credit Karma. To build such a rich experience that supports web, Android, and iOS natively would take much longer than just a week of work. What really enabled this was a platform that we built internally to create new user experiences. Very unfortunately, it's named Containers. But looking past that, Containers leverages React and GraphQL to make it extremely easy for developers to create new experiences. So in this talk, first I'll run through some of the problems that we faced in the company in Credit Karma that led to the inception of Containers. Then I'll describe its architecture and show how it kind of looks in practice. And finally, I will be sharing the lessons that we learned after using containers in production for a year. So let's start off with some history of containers. What I'll do here is run through an engineering thought experiment and talk about some of the problems that we might run into and some of their common solutions. So we start off with this very familiar scenario. A product manager walks into the room with a PRD. Whew, it's an exciting time. And they ask for the following feature. Can we add a new page that shows members the benefits that they're eligible for? And attached to a PRD is usually a very beautiful design made in a proper design tool like Figma. As for me, I created this wonderful piece with Microsoft Paint. Maybe I should look into being a designer, eh? But jokes aside, you can see that from this low fidelity design, we're creating a new page that displays the benefits that a member is eligible for. We mocked 3 of them here, each showing the following: the name of the benefit, the description of the benefit, the expiry date of this benefit, and also a link to this benefit. So the next question to engineers are, how should we go about implementing this? And that's simple. From my first impression might be, let's just add a new GraphQL service or a module. And as you can see from this diagram, the benefits GraphQL service is something that we're creating and adding. It will connect to our domain services where it can fetch benefits, and then they will be rendered by our web, iOS, and Android clients. And diving a bit deeper into the GraphQL layer, we create this benefit type that contains the data fields that we need in order to render a benefit on the page. So this type will contain a benefit ID, its name, a description, a URL, expiry date, and a type. When the clients make a GraphQL query for this benefits data, they'll receive an array of these benefit types. And next we have, so what happens exactly once we have a benefit type? On the clients, let's take a look at web, for example. Number one, basically, the next part is once the client receives a list of these benefits, sorry about that, my slides kind of got wonky here, but what does it do with this data? This is known as the application logic, and in our web client, we implement this with React. So diving right in, we define a benefits card React component, which takes our query data and renders a list of benefit cards. So as you can see, there's a lot of custom logic in here to transform the raw data from the benefit object into what the user sees. So for example, we have a name that has a fallback using the benefit type. We have an expiry date, which has a formatter function. And we also have a default URL for the anchor. And then it's also hard-coded with a text of go to benefit page. And the key point to note here is that the clients are the ultimate arbiters of what the UI looks like. Application logic is written on the client side to transform the raw data from the queries into something that is presentable to the users. And as I mentioned before, this is what like the React client might look like, the web client where we write this application logic. And this presentation logic will also have to be duplicated and re-implemented in iOS and the Android code bases as well. And to quickly recap this data flow, a client first makes a request to the benefits GraphQL service to retrieve a list of benefits. And then the GraphQL service will then talk to the appropriate domain services to get the data that it needs. Then the benefits GraphQL service will then transform the data to conform with the benefit schema and respond with a list of benefit to the client. Finally, the client will execute application logic to transform the benefit type into pixels to render on the screen. And so we have this issue of duplicated application logic in each of the clients, as it needs to be repeated on web, iOS, and Android. Imagine needing to fix a bug or to change some functionality in the presentation layer. This code change will need to be repeated in 3 different code bases and have to go through 3 different a release process for each one of these platforms individually. This can have a compounding effect. More time is taken to implement this. It'll take more time to ramp the experience. And you're also 3 times more likely to make bugs because you're writing the same code 3 times. And to really illustrate this point, let's consider an example where we're actually changing how the data is formatted. In your React code base, you'll just need to go into the getExpiryDate text function and update it. And then you'll need to repeat the same thing in your Android code base and the iOS code base as well. And hopefully, you didn't make a bug in any of these changes. And to make it even worse, not every user updates the apps on their devices right away. So it might even take some more time before your end users can even receive the updated builds with the date change or the bug fix. And this could potentially take months before a user updates their apps. So to solve this issue of duplicated application logic, we introduced the concept of a view-centric schema as opposed to the previous data-centric schema. This is also known as backend-driven UI. And in this new view-centric schema, we define a type benefit card. And the fields in this type define how the data should be rendered instead of just serving the raw data itself. So instead of having fields like the benefit's name, description, expiry date, we replace them with fields that correspond more directly to the final presentation, more generic types, such as primary text, which will contain the benefit name, secondary text, which will contain the benefit's description, and description, which will contain the expiry date, and an anchor type, which will contain both the anchor text and the link. So to really drive my point about view-centric schemas, let's take an example with the expiry date. We first take the data-centric expiry date field, and then we combine it with a text formatting application logic. And so you'll get this new view-centric schema where your description field is a string, and the logic to transform the expiry date and formatting to the string will be defined inside your benefit card resolver to power the description field. And we also do the same for all the other fields, the primary text field, description, secondary text, anchor. We move all this application logic from the clients into the benefit card resolver, and this is the result, a benefit card schema that matches one-to-one with the benefit card renderer in React and the different platforms. And a view-centric schema design comes with one main advantage. That is, the application logic is centralized in the GraphQL layer. This means that the clients become simple renderers. There is now a clear separation of concern between the rendering logic and the application logic. It's easy to identify where bugs are located because rendering bugs will be isolated to the simple renderer clients, and then the application logic bugs will be isolated to the GraphQL layer. So you always kind of know where to look. There's also reduced code duplication. There's no more need to write the same application logic in all three platforms. There's now going to be a single source of truth for this logic in the GraphQL layer. This saves times and potential bugs. And finally, updates. With a view-centric approach, we can make certain updates to native without cutting new native builds. This means that you won't need to cut a new build for things like copy changes, for experimentation, as long as they're within the constraints of the view-centric schema that you defined earlier. In this benefit example that I showed, this is limited to text, but we can see more powerful implications of this later. And this isn't to say that there are no cons of view-centric schemas. There are some, such as having lower resilience to changing UI requirements, and it won't really support more complex use cases. However, these trade-offs are worth it to us, and instead we kind of use extension points and escape hatches when needed. So everything is fine and dandy now in schema land, right? I mean, we have a reasonably well-designed benefits page that's view-centric. So let's zoom out of our system a little bit and take a look at the bigger picture. Across the company, we have many different GraphQL microservices that use many different custom view-centric GraphQL types. For example, we mentioned a benefit card in our newly designed benefits GraphQL service. But other services at the company, such as the dashboard service and the offer service, might define their own card types, which closely resemble a benefit card, but with some slight differences. So as you can see here, custom types being returned in each place. And correspondingly, our clients defined across the different pages and platforms will implement slightly different renderers for each one of these slightly different types. And what this results in is chaos. Here's a real-life problem that we actually had at Credit Karma. In 5 of our pages, we had 5 different credit card account components, which were slightly different. Let's take a look at how they look. That's number 1, 2, 3, 4, and 5. Can you spot the differences? This isn't limited to just the credit card account components either. We also had this issue with back buttons, modals, tooltips, and all sorts of common components. So how do we solve this? We share the view-centric GraphQL types, and we use a common rendering library. We can unify all these fragmented types across the organization and have a standard set of view-centric types that are applicable to a wide variety of use cases. And then we create a shared rendering library that is used by all the different pages to handle these different view-centric types. This rendering library will then be implemented in React, in iOS, and Android to handle all the different platforms. And so to recap the two main issues I described that we faced at Credit Karma that led to containers, one of them is having duplicated application logic in each client, and we aim to solve this via a more view-centric GraphQL schema design. The second one is the issue of inconsistent design due to fragmented GraphQL types and renderers across the organization, which we aim to solve by sharing types and renderers. And in addition to these two primary issues, we also have some other requirements that we want to factor in when building like new infrastructure and products. Things like experiments, metrics, maintainability, scalability, and most importantly, velocity. We need a system that will support all of this. And this is where Credit Karma Containers comes in. Containers takes the lessons from code duplication and design consistency problems and combines them with some other parts to meet our product needs at Credit Karma. So I took this definition directly from our internal documentation. One, it's a platform for building personalized product experiences faster. And secondly, is not related at all to Docker containers, which I find pretty hilarious that this needs to be part of the definition. If someone has any experience with changing internal nomenclature at a company after it's widely adopted, please send me some tips in the chat. I'd love to know. The anatomy of containers consists of three main components: a component renderer, a view orchestrator, and a data gateway. The first is a component renderer, which handles rendering GraphQL types that implement our company's design language. These renderers are available as libraries in both web and native. The next is the view orchestrator. This is a service that takes declarative configuration files, which specify sections and pages, as well as many other dependencies, and it outputs GraphQL types that our component renderer can understand. And finally, we have the data gateway. This service serves data points about a user that can be used by the view orchestrator. And then these can be used along with a template and transformations needed to turn them into view-centric fields. Or they can be used with eligibility rules on the view orchestrator sections to determine whether a user can see a specific section or not. And used together, these three components really gets us the benefit of fast product cycles, which is exactly what we did for Project Relief. And to illustrate like putting together the component renderer, the view orchestrator, and the data gateway, we get an architecture that looks like the following. So let's walk through a request flow when a member interacts with a containers powered page. So first, we load up a specific surface on our phone or our laptop. The front-end client in React will then make a GraphQL query to get a section to show on that specific page. Then in the GraphQL resolver, there will be a view orchestrator client, which will then make an RPC call to the view orchestrator to fetch the sections to display. And a lot of magic happens in this view orchestrator. In the view orchestrator, we get the appropriate data points from the data gateway, the appropriate templates from the templates database, and compile this down into a JSON representation of the standard GraphQL types. This will then be returned to the front-end client, where the component renderer can render the standard GraphQL types, taking care of the spacing and the layout. And Credit Karma's design system consists of all the components that you would need to build a full-fledged experience. Think things like buttons, cards, tables, and form inputs. All of these will have their own GraphQL types. And a set of these types will be passed from the component renderer, will be passed into the component renderer, which can take care of the arrangement and the spacing. And one cool thing about this is that it's a living design system. That means that this ecosystem is constantly evolving to support more and more use cases. The idea is that we invest some additional initial effort once we do something, and this will make it become a solved problem that others can reuse and use in their experiences. So something like memoization. Now, recall from the architecture diagram that the view orchestrator had an arrow that pointed to a database of templates. Here's an example of a basic template that renders something similar to the benefit card that we showed earlier in the presentation. Its type is a Fabric article card, and it declares a title, a subtitle, description, and button fields. The parts surrounded by the curly braces are injected with data points from the data gateway, and transforms can also be run on this data to add some view-centric flavor. And now this will be processed by the view orchestrator, and out comes a GraphQL response. As you can see, we have our title, our subtitle, and a button in a format that's conformant with the GraphQL schema that we defined, and something that the component renderer understands. Additionally, the view orchestrator also automatically adds tracking metadata when it's compiling the template into GraphQL output. This allows us to collect a bunch of behavioral metrics that we might be interested in for experimentation for free. So taking the view orchestrator template that we wrote above, we eventually get a card that looks like the following, rendered by the component renderer. Pretty neat, huh? But for all of this to actually happen, we need to do a bit of plumbing work in the view orchestrator. So let's take a look at what the YAML configuration for the section in the previous slide looks like. It declares several key parts. A unique portal ID. This will be used to uniquely identify, a unique section ID. This will be used to uniquely identify the section in the page. A template ID. This binds a specific template from the template database to a specific view in the view orchestrator section. The view orchestrator will then take this template and its required data points and process it into a standard GraphQL type, which can be handled by the component renderer. Finally, this section includes the tracking metadata, which will be consumed by the component renderer to fire tracking events. And finally, we have the section's eligibility rules. This is really the bread and butter of what a section looks like. It uses our internal eligibility language as well as member data points in the data gateway to determine whether or not a user should see a specific section or not. And to tie together, the second entity of the view orchestrator is the idea of this page. Does this look familiar? It's the beautiful benefits page, which I wireframed earlier. A page can be thought of as a composition of sections. And in Project Relief, we actually have hundreds of sections on a single page. Notice how we can arrange the sections in a page configuration, depending on the member's eligibility for different sections on the page. Depending on what sections are put in this configuration, and what the eligibilities are like for different members can actually see significantly different pages. And in this specific page configuration, I defined 4 sections. As you can see, there's 1 section for the header and 3 benefit card sections. And that gets basically, if a user was eligible for all 4 of these sections, they would see what I show on the left. So putting it all together, here are the different steps needed to create a new page at Credit Karma. We create data points in the data gateway, if needed. Then we create templates in the view for the view orchestrators to consume, if needed. And then we configure sections in the view orchestrator to bind templates and add eligibility rules. And finally, we configure pages in the view orchestrator to compose sections. And that's it. Your page will be served somewhere once you push the launch button. And ta-da, leveraging the Containers ecosystem, we spun up a bunch of different pages, hundreds of sections, and here is the end result, Project Relief in less than a week. So we have all 3 platforms supported natively with a backend-driven UI. And it has now been over a year since the inception of Containers, and we extensively used it in production for many experiments and projects, including Project Relief. We learned a lot of things. The thing that went well with Containers was that it was able to solve the problems that we designed to solve. Phew. The time that it took for us to ship products improved greatly. By being configuration-driven and taking away the developer concern for UI logic, we were able to reduce the time it took to transform an idea into production. There was less time spent trying to play whack-a-mole on UI bugs and reinventing the wheel. We were also able to solve our design consistency problem. Due to our shared GraphQL types and the common component renderer, presentation logic for components and spacing is no longer really a concern of the product engineers, but instead they were solely focused on by a focused design and engineering team. And additionally, new components were contributed back into the design system, which made it very easy to reuse components from any existing experience. And finally, data-driven design was encouraged. With containers, we were able to have this short product iteration loop. And behavioral tracking came for free as well. With this combination, teams were able to make decisions like, is there high engagement on this page? Are there members dropping off in this funnel? Is there some benefit that users are using less than others? Does putting this card here cannibalize from another card? So we were able to learn from and iterate really quickly from all these data and insights. However, this one-year journey was not smooth sailing all the way. We learned many important lessons. The first one is that documentation is of paramount importance. This is especially true when we design a new paradigm for developer workflow. Without good documentation, there will be a much lower adoption rate for technology, and bad practices can and will form. Work closely with product partners who will pioneer your tech and ask for early feedback. Another thing are extension points. These are necessary. There are going to be a million edge cases that you won't account for, and you can't expect to solve every problem with the library that you build. For example, what if we want to do custom components? What if we wanted to integrate with third-party widgets, support for interactive experiences, support for progressively migrating to containers? Without extension points and escape hatches, many teams will find it hard to justify migrating to your tools. The friction will just be too high. Give your developers the ability to break the rules when it makes sense. And containers was initially built to serve read-only experiences, and it did that quite well. On the server side, we can define what we want to render. But then how do we exactly define client-side interactions, form submissions, things of this nature? In the end, we went with a pub/sub model for components, but it actually ends up being a little bit complex even for a fairly simple task, and we're still actively working on solving this problem. Build tools and empower your quality engineers to do their job. Give them ways to mock data points, give them ways to simulate different sections, eligibilities in a test environment. One of the initial issues that we had early on was actually a lack of quality engineering tools. This made it really hard for our quality engineers to exhaustively test any pages built with containers, which increased our risk and our uncertainty. And finally, at Credit Karma, we learned that we shifted the organization so that the design team would work extremely closely with the containers engineering team. This really helped to facilitate communication between two extremely coupled teams. The design language should be agreed upon by both teams with a strong mutual understanding of the current component support level. And finally, there are still some problems with containers that need to be solved. As we add more and more components into our design system, the component renderer grows larger and larger in size. And this is pretty problematic, especially in the web world, because a large bundle size means that the initial load of your page will take longer. Perhaps the solution would be to dynamically load a page, to dynamically load renderers only when needed. Another issue was caching, and this is kind of due to the view-centric nature of containers. When navigating between different pages, a new GraphQL request will need to be made to refetch the sections for a particular page. Otherwise, there's no guarantee that some data points about a user has changed, and thus their eligibility has changed for specific sections, and then the sections to render on that page will also need to be different as well. And finally, as I mentioned before, Android and iOS members may be on outdated app versions, which won't support newer GraphQL types. And so even though the component renderer is designed to fail gracefully, when we define templates, we will also need to take these different versions into account. Like, for example, if we have some new button type that we want to render, and this isn't supported by an outdated version of the Android version, we can't just be like, oh, let's just hide a button and miss a button. We'll need to take these different versions into account and render some sort of fallback UI. And this kind of litters the templates with fallbacks and version checks. And that concludes my presentation. Thank you for listening. Go build something cool. And as mentioned before, my slides can be found on my website at climbing.ninja/reactgeekcode2021. And I finished way earlier than I expected because I spoke way too fast.
It happens. It happens. I have to say, the comments in the comments section are absolutely blowing up. People Loved your presentation. A lot of them could relate to basically everything you said. There were so many comments on the animations and things like that. Wow, what a great speaker. Thank you. So I think you did absolutely amazing. We can give it maybe a minute or two since we still have 10 minutes.
Mhm.
To the audience, I'll say if you have any questions that you want to ask now before the Q&A, this is your chance. We have 10 minutes to fill up, basically. If not, we can go for a break. But while people come up with questions, um, speaking too fast, I was listening and like I could keep up, but I was thinking like, wow, we still have 10 minutes and like it sounds like it's coming to a close, but I wasn't sure. And here we are. So I have to say that truly, it's not often that this many people like comment on how happy they are. Everyone, like I said, if you want to ask your questions, ask them now before I let Clement go. And anyway, well, hopefully the questions come in. So where are you based right now?
So I'm living in San Francisco in California right now.
Aha, wonderful. I've been there on a holiday, and I have to say it was I hope I don't offend anyone by saying this, but when I was there, everyone hyped it up so much, and you see it in like the movies and things like that, and it looks so beautiful. And the 3 days that I was there, it rained every
Oh
single
no.
day. It was miserable. It was absolutely miserable. And the whole time I was like, what's the hype? Why do people like it so much? But it is a beautiful city, gorgeous. Sadly, I never got to go to Alcatraz, which was like
Mhm.
the high point of my trip because we just didn't get a chance to go, but that would have been fun. So hopefully next time I'm in San Francisco. Oh, someone's asking, well, we have a serious question, but someone's asking, what are the benefits of San Francisco? Tell me some good things.
The benefits of San Francisco. Well, I would say San Francisco is definitely usually kind of known for its weather. At
Mm,
least it doesn't
that's what they
always
say,
actually.
apparently.
I feel like in the past we've been like under a drought for a really long time, so there's actually no rain for like years. And now I guess you just came at a really bad time where it happened to rain for 3 days.
Yeah, it was Christmas time, by the way. Maybe that affects it.
But that's actually so that's at least one selling point. I really enjoy sweater weather.
Mm,
So for me, like I like wearing my many layers and just going outside. And then if I'm getting a little bit cold, just take out a sweater, walk into the sun. And then if
yeah.
it's getting too hot, you just walk into the shade. Like San Francisco is kind of known for its microclimate culture. So
Yeah.
wherever you cross the street and just gets like 20 degrees colder or something.
Oh, wow. That's a big difference. So now the questions are popping up. So
Mhm.
am I wrong? But what do you have to say to this?
So, well, when I made this point, I was gonna say I'm the chief eating officer of Credit Karma. You will always find me in the kitchen.
That's amazing. That is, I think that's the best person to be in a company, to be the one like with the snacks, always knowing who to find if you're hungry. Amazing. Okay,
Also,
so
mhm.
here's a serious question. If we wanted to introduce a container system that you described to our team from scratch, would you have any advice on where to start?
Yeah. So first of all, I would really urge you to evaluate like what are the needs of like what are the problems that you're trying to solve? What are the problems that you're facing in your team currently? Is the issue this duplicated application logic, right? And is the issue this idea of having very fragmented designs and types? And if this is the case, then maybe you do want to look into like some system similar to containers. And I will kind of reference back to my slides where I describe the three main parts of containers. One specific thing that I would like that one like big point of containers is the view-centric part of it, the idea of backend driven UI. So define your renderers on the client side, define what those renderers can render on the backend, and just build it out using technologies that you're comfortable with. And in the case at Credit Karma, we had a lot of like expertise in React for the front end side, and we also had a lot of like expertise on GraphQL for the backend side. So that's kind of how the technology gravitate towards those.
Great answer. Here's another question, which is, can containers be implemented without GraphQL?
Mm-hmm. And so this kind of follows along with like what I mentioned earlier, right? Use the technology that you're comfortable with, and containers can definitely be implemented without GraphQL. So actually, I guess for example, like even something like GraphQL can be implemented without GraphQL. For example, you can have some REST endpoint that specifically queries for different fields that you want, although that would be a lot more work. I think GraphQL definitely makes it easier, but yes, like if you just have like endpoints to define like, what are the shapes that your renders can handle, either through like a credit, like some some normal like REST endpoint, and then just have clients that will take those types that it returns back and render those. That should be enough to implement something similar.
Amazing. We still have a couple of minutes, so let's do a couple more questions. So how would you pitch containers to a less technical PM?
Oh, that's a good question. And the way that we pitch containers to our PMs at Credit Karma was, it'll help ship things faster. It'll make things more reusable. It'll make it easier to have data-driven design. So
just really selling it.
I think that's the idea of it, and that's basically what containers was created to do. It was created in order to make developing similar like experiences much easier. Like I think with complex experiences, it'll be hard to make containers to support those use cases. But for very common tasks, like you want to render a page with different sections on it, with different cards, and they're composed of some standard like design language that you reuse over and over again in the company, this is a problem that's already solved, and you don't need to solve this problem over and over again, which leads to a high fixed cost every time you want to solve this problem. And so this is where containers comes in. You can reuse solutions that you built before and just really quickly like ship things that you have like kind of shipped in the past.
And let's do one last question before the Q&A. So if you do send in a question, we will cover it in the Q&A, but let's do the last one for now. So is container code designed to be written by developers or other teams?
Okay, so let's see. Containers is designed to be written by developers first because it is configuration that's stored on GitHub. But what we're trying to transition to is being able to make it a bit more hands-off in terms of for developers. So there is some work being done internally right now to, for example, create like drag and drop UIs that would like the core of containers was, I mentioned in the Vue orchestrator, we had configuration files, right? So these configurations are just things like, are users eligible to see this section? What should this section look like? And in general, like section templates can be kind of built with drag and drop UI. There's like lots of products out there that kind of try to solve this with what you see is what you get editors. And then there's the idea of eligibility tools, which is, can the user see this section? So these can also be done via like some kind of like UI template builder thing. And then finally, we can have some kind of tool to compose all these different sections that we create onto one specific page. And this is all something that can be done through an intuitive tool. It's basically the idea of, instead of writing it in a config file, you have a tool to, write your config in an easier way. And so even less technical people can consume this.
Amazing. Right. Okay. So that's it for now then. Thank you so much, but we're not saying goodbye. We'll see you very shortly. So thank you and see you soon.
Thanks for having me.
Bye.